Hi everyone, this is Mrs. GA, and today we're going to learn how to graph tangent with stretches, shrinks, reflections, and translations. So we're going to start by looking at the parent function for tangent. So tangent looks really different than your sine and cosine functions in terms of our trigonometric functions. So you can see on the left here we have one full period of a tangent graph. So the first thing you might notice is that our tangent graph has vertical asymptotes. So that's because if you're looking around your unit circle, there are actually many values where the tangent is undefined. And whenever we have an undefined tangent value, again, we have a vertical asymptote. So our parent function will always have a vertical asymptote at negative pi over 2. The way we write that as an equation is here, x equals negative pi over 2, and then we'll have another one at pi over 2. So notice that they are pi units apart. So again, the distance between your asymptotes is pi units. So that's why we say that the period of tangent is pi. So that's also different than sine and cosine. For sine and cosine, the period is 2 pi. It takes 2 pi units to repeat itself. For tangent, it only takes pi units to start repeating itself. So that is another different thing about tangent. And then in terms of graphing in between, there are more points than we're going to be using on this graph. I'm going to ask you to use 3 key points to graph these functions. So the first key point is here at negative pi over 4, negative 1. So this is negative pi over 4, and then we go down to negative 1. I'll plot that here. Right here. And then our next key point will be 0, 0, which is right here. And then the last key point we'll use is pi over 4, 1. And you'll notice that if this is 0 and this is negative pi over 2, negative pi over 4 is right in halfway in between, and same thing between 0 and pi over 2. So those are the 3 key points that we'll use, and then we can transform them accordingly. And again, tangent is undefined at negative pi over 2 and pi over 2, which is why we have asymptotes. We'll also make sure to always include our asymptotes, and we can apply transformations to those in the same way that we would our key points. So again, this is what the parent function looks like, and then we're going to apply those same transformation rules we've been working with all year to help us change our graph. So here's the general form for the transformations of tangent. So again, you're going to see a lot of really familiar things here. First, you're going to see that a value, so the vertical stretch or shrink, same place as any other function we work with. And again, you can achieve that by multiplying all of your y values by a. The next thing you might see is that minus sign out front. If you have a minus sign, it's a vertical reflection over the x-axis. So you multiply all of your y values by negative 1. You also might see adding or subtracting from x, specifically grouped with x. That's going to be a horizontal translation. And it's going to shift your graph left or right. And again, we can achieve that by adding or subtracting h from our x values. And then the last would be a vertical translation, that plus k. And we can achieve that by adding or subtracting k from all of our y values. And one thing I want to point out, anything that applies to our x values, which you see here, we can also do to our asymptotes. So if we're going to shift our coordinates left or right, our asymptotes will shift left or right as well. So just like we're doing with sine and cosine, we're always going to follow PEMDAS when we're applying our transformations. So we always do multiplication before we add or subtract. All right, so for each of these, we're going to graph 2 full periods of our functions, and then we're going to make sure that we include 3 exact coordinates per period as well as the asymptotes, and then we're going to determine what is the period of our function and what are the equations of the asymptotes. So the first one is just 2 times the tangent of x. So first let's start by doing our key points and our asymptotes. So our key points were negative pi over 4, negative 1, 0, 0, and then pi over 4, 1. And then we did have asymptotes at x equals negative pi over 2 and x equals pi over 2 for a parent function. And then the only transformation we have in this case is that vertical stretch by a factor of 2. So we're going to multiply all of our y values by 2. So since this is a vertical transformation, it is not going to affect our asymptotes, so those are going to remain unchanged. So our new points are going to be negative pi over 4, negative 2, 0, 0, and pi over 4, positive 2. And again, our asymptotes are going to stay in the same spot. So let's start by graphing our asymptotes. I know it's really hard to see in this graph, but it is counting by pi over 4 on my x-axis is pi over 4, pi over 2, 3 pi over 4, etc. So I'll do my asymptotes first with a red dotted line. Here's x equals negative pi over 2, x equals pi over 2. And then we have our 3 key points, negative pi over 4, negative 2, 0, 0, and pi over 4, 2. If you remember from the parent function, it kind of makes that like S-shaped graph almost, so we're going to make sure to try to achieve that same shape, but it is a little bit stretched out. And then our graph is going to go down infinitely on the left here. It's going to get closer and closer to our asymptote, but it will never quite touch it, and then it'll just keep moving up infinitely to the right. So let's repeat this pattern again. It asks us to only graph 2 full periods, but see if we can do maybe one on the right and one on the left just for practice. So if we notice here that our asymptotes are pi units apart, so from negative pi over 2 to pi over 2, we can continue that pattern, and if we add another pi units, I'm going to have another asymptote. So I'll have an asymptote I would have one at 3 pi over 2, and I can do the same to the left. I can go pi units to the left, and I have one at negative 3 pi over 2. And then we see, okay, if we're going to just repeat this same graph in each of these regions, we have that point right in the middle. And then at the halfway point in between here, we're down at negative 2, so I can do that here. And then halfway between these, we're up at positive 2. So again, we're just going to repeat that same shape every period, so between each new set of asymptotes. So here's the middle, down at negative 2, and up at positive 2. So this would just repeat over and over and over again every pi units. So our period is still pi, that's how long it takes tangent to repeat itself. And then our asymptotes, let's list all of them that we drew. We have one at x equals negative 3 pi over 2, at x equals negative pi over 2, x equals positive pi over 2, and x equals 3 pi over 2. So notice they are all pi units apart. If I add pi, I would get to my next asymptote. All right, let's try another one together. So here I have 1/2 tangent of x. So same thing, let's start with our 3 key points in our asymptotes. So we have negative pi over 4, negative 1, 0, 0, and then pi over 4, positive 1. And then we have x equals negative pi over 2 and x equals pi over 2. So here I see one transformation. We have a vertical shrink because it's less than 1 by 1/2. So we're going to multiply all of our y values by 1/2, and our asymptotes are unchanged. So here's my 3 new points. Again, my asymptotes remain in the same place. So I'll start with those, negative pi over 2, positive pi over 2. And then we have one at 0, 0. And then halfway in between at negative pi over 4. Now it's just at negative 1/2, and then at pi over 4 it's positive 1/2. But it still makes that same kind of S-shaped shape, and again on the left and right it's going to approach your asymptotes. Okay, let's repeat that going to the right. So we can go pi units to the right, draw another asymptote, pi units to the left, draw another asymptote, and then just repeat the pattern. Here's our center, and then here it's at negative 1/2, and here it's at positive 1/2. And again, center, negative 1/2, positive 1/2. So notice that our tangent functions within each period, they're going to be increasing. So it's going kind of low to high, low to high. And of course that would be unless there's some type of reflection. So our period is still pi. That's how long it takes tangent to repeat itself. And then the asymptotes that we drew, we have x equals negative 3 pi over 2, x equals negative pi over 2, x equals positive pi over 2, and x equals positive 3 pi over 2. All right, let's try another one together. So again, starting with those same key points, negative pi over 4, negative 1, 0, 0, pi over 4, 1, and then our asymptotes. And then let's look at the transformation we see. Here we have a vertical reflection, so it's going to reflect over the x-axis. And again, we can achieve that by multiplying all of our y values by negative 1. And again, this is not going to affect the asymptotes because it's only affecting things involving y. So our new coordinates are going to be negative pi over 4, positive 1, 0, 0, pi over 4, negative 1. So let's start with our asymptotes, which were unchanged. Negative pi over 2, positive pi over 2. Let's do another one on the right, 3 pi over 2. They're just repeating every pi units. So we still have that point right in the middle at 0, 0. This time at negative pi over 4, instead of being down here at negative 1, now it's at positive 1. And then we have pi over 4, negative 1. So it's still going to make that same S-shaped curve. But this time we're going to be going from high to low. So now it's a decreasing graph within each period. And then just kind of repeat that pattern in each period between your asymptotes. Just like this. And there you have it. So again, our period is still pi, and that's the distance, the length that it takes for a tangent to repeat itself. And we have asymptotes at x equals negative 3 pi over 2, x equals negative pi over 2, x equals positive pi over 2, x equals 3 pi over 2, and again, this would just keep repeating every pi units. Okay, so let's try another one together. Here we see that we have some type of translation because I see a plus sign. So again, we always start with our key points in our asymptotes. Negative pi over 4, negative 1, 0, 0, pi over 4, 1, and then x equals negative pi over 2 and positive pi over 2. Okay, so this time I see that we have plus 1 to our entire function. It is not specifically grouped with the x, so it must be a vertical translation. This is actually going to shift our graph up 1. So we can add 1 to all of our y values. Again, this is not going to change where our asymptotes are. Those are going to stay in the same place for now. So we have negative pi over 4, 0, 0, 1, and then we have pi over 4, 2. Then our asymptotes are still in the same spot, so let's start by sketching those in. Again, they're just going to repeat every pi unit. Okay, let's plot our points. So we have 0, 1 right in the middle, and then for negative pi over 4, it's 0, and then for positive pi over 4, it's at 2. So we're going to keep that same S-shaped graph, except you can see that instead of being centered at the origin, it's been shifted up 1. Then we can repeat that pattern here. And just for extra practice, we can even do another one on the left. So our period is still pi, it's unchanged, and our asymptotes are still in the same location they've been so far. So negative 3 pi over 2, negative pi over 2, positive pi over 2, and 3 pi over 2. All right, so here I see a couple of transformations, so we'll work through this one together as well. Let's start with our key points. So we have negative pi over 4, negative 1, 0, 0, pi over 4, 1, and then our asymptotes. X equals negative pi over 2, and x equals pi over 2. So I'm going to start with the two transformations I see involving multiplication. So I'm going to group them together, but it is two separate transformations. So we have the reflection over the x-axis, so that vertical reflection, and we have a vertical shrink by a factor of 1/2. So since they both involve our y value, I can simply multiply all of our y values by negative 1/2. I can do both at once because they both involve multiplication. So this will not affect our vertical asymptotes. So let's apply that transformation first. So 0, 0, and then pi over 4, negative 1/2. And now we can look at the transformation involving the subtraction. So this will shift our graph down 3. So now we can subtract 3 from all of our y values. So again, we always do multiplication transformations before we do addition or subtraction. Okay, let's see what we get. Here we get negative pi over 4, negative 5/2, 0, negative 3, and then we have pi over 4, and then we have negative 7/2. So make sure to write your fractions as improper fractions. We don't really use mixed numbers when we're working with our trigonometric functions. All right, let's start graphing. So again, I'm always going to start with my asymptotes, just because it gives me like a nice region to graph each of my periods. Okay, so our center point is out now at 0, negative 3, so here. And then we have negative pi over 4, negative 5/2, which is negative 2.5. And then we have positive pi over 4, negative 7/2. So you can see since we have that reflection, we now have the decreasing graph, and you can see that it is kind of squished down, and it has been shifted down 3. So we can repeat that pattern in the other two periods. So here's our middle, and then it's at negative 2.5, negative 3.5, and we can repeat it once more here. And there you go. So our period is still pi, it's not changed, and then our asymptotes are still in that same spot. They won't always be, but for now, all of them have been unmoved. And there you have it. All right, we're going to try one more together. So again, we always start with our 3 key points and our asymptotes. Negative pi over 4, negative 1, 0, 0, pi over 4, 1, x equals negative pi over 2, x equals positive pi over 2. Okay, so here, sorry, we have a little typo. It should only say x one time. So just imagine that was gone. Okay, so here I see that this time we actually have a horizontal translation. It's grouped with x, so I know it's horizontal. And since it's addition or subtraction, I know it's a translation. So this is actually going to shift our graph to the right pi over 4 units. Remember, it moves in the opposite direction for anything grouped with the x. So we can achieve this by adding pi over 4 to all of our x values. So plus pi over 4, plus pi over 4, plus pi over 4. And since it's affecting x, we can also apply the same transformation in the same way to our vertical asymptotes. Those are going to shift over as well. So this gives us 0, -1, pi over 4, 0, and then pi over 2, 1. So 1/4 pi plus 1/4 pi is 1/2 pi. And then our asymptotes, again, are also going to be shifted. So this one is going to shift to negative pi over 4, and this one is going to shift to 3 pi over 4. So to graph, let's start with our asymptotes. So here's negative pi over 4. Here's 3 pi over 4. And again, let's just continue that pattern. They're still going to continue every pi unit. So notice the distance from here to here is still pi. So we can count 1, 2, 3, 4, another pi units to the right. So it's 7 pi over 4, and we can go even pi units to the left. And then let's plot our points. So we have 0, -1, pi over 4, 0, and pi over 2, +1. So you can see it's still that same shape. We still have the point right in the middle, and then one halfway in between going to the right and left. And we can still repeat that pattern in each period between each set of asymptotes. And since there wasn't any type of reflection, it's going to be that increasing graph for each period. There you go. So our period is still pi, but now we have new asymptote equations because remember those have been shifted over. So I see here we have one asymptote at x equals -5 pi over 4. We have one at x equals -pi over 4, x equals 3 pi over 4, and x equals 7 pi over 4. Again, we can just find our next asymptote again by simply adding pi. So if I have -pi over 4 and I add pi, it's 3 pi over 4, and I add another pi, it's 7 pi over 4. And we can continue that pattern infinitely to the left or right. Okay, here's our last example. This one is for you to try on your own. So please pause the video, and when you're ready to check your work, you can hit play. All right, go ahead and check your work here because there's a lot going on. So first I'm going to address these two transformations. So we have a vertical stretch by 3 and a reflection over the x-axis. So you can see I multiplied all my y values by -3 to do that first. And then we can shift our graph left pi over 4 and up 2 by, again, subtracting pi over 4 from our x values and our asymptote, and then adding 2 to our y values. So here we get these 3 points, and here's 2 of our asymptotes. And then we can just repeat that because our period is still unchanged, so you can see the distance between our asymptotes is still pi units. So you just repeat it in the same way we've been doing. So notice for this one now we have the decreasing graphs because of that reflection, and it is pretty stretched out. I notice, for me at least, the more it's stretched out vertically, the harder it is to achieve like that curve when you graph. So just do your best. And here's the asymptotes that I graphed. Okay, so that is all for today's video. Thank you so much for watching.